Good morning, everybody. My name's Jason Fox. I'm the Senior Technical Evangelist of the FIWARE Foundation, and we're continuing our FIWARE webinars, our Wednesday webinars, with a session on combining NGSI-v2 and NGSI-LD. So let's see what we're going to be covering this morning. We're going to be describing the core use cases of both NGSI-LD and NGSI-v2 and explain what the differences are. There's reasons for using both. And obviously, you want to use the right tool for the job. It's also a case of working out, what is the best practice for structuring your V2 data and describing what the data types of that data are. Because obviously, the whole point about the NGSI interfaces is that they are a well-defined structure which is usable by other systems, so you can break your system into microservices. Then with more detail, and this is where the main meat of the system is. We're going to see how to use these context brokers within data spaces. You only really need to use LD if you're considering using data spaces. So this is where things like your at context and JSON LD expansion compaction and things like that come in. So let's move on. Fundamentally, NGSI-v2 is a JSON-based API. Every competent developer understands what JSON is. It's your curly brackets and your key value pairs, and it's been extended. To become the NGSI-LD protocol. NGSI has got a long history. It's been developed from a telephony API. I believe that FIWARE, the original FIWARE project, is approximately 10 years old. The FIWARE Foundation is about 6 years old itself. So, and obviously, FIWARE didn't come from nowhere. It's a case of you take an existing concept of what context data, and you come up with a API to use that context data. Indeed, there was an NGSI version 1 before moving on to NGSI version 2, which is JSON. Both NGSI v2 and NGSI LD are REST APIs. But the LD bit of NGSI LD is because NGSI LD is JSON LD. Now, JSON LD is an extension of JSON, and the idea behind that is that you can modify your payload slightly so that you can gain additional interoperability in data spaces. NGSI v2 itself, if you've got control, it doesn't need any of this JSON LD context, doesn't need any of this expansion compaction or whatever. And when you are in full control of your system, you get the benefit of interoperability through layering your microservices, and you are able to use all of this without the JSON context. This is an example of a NGSI v2 payload, and you can see, as you'd expect, every entity must have an ID and a type. And the other attributes beyond the who are you and what are you depend on the system being described. So in this case, I have a IoT device, and it's got a category of sensor. It's a sensing device, and it's following the smart data models convention, where it's saying, okay, I am a thermometer, I have a temperature of 26 degrees, and you can look in the metadata within that temperature, say 26.6 what? Well, you can see there, the great thing about JSON, of course, is it's relatively human readable. You can see that there is a unit code saying that this is 26 degrees Celsius, which is a warm summer's day. And there are other examples of metadata. For example, the time instant, which is usually generated by the IoT agent, which will tell you, okay, this was done in May, or in this case, you have another attribute, which is controlled asset. Where is the device, or what is the device measuring? and it's saying here there's a relationship to building 001. But as you notice, all of the types have got different different names. There's nothing, and the value is always a value. So the type and of always a value. And it's only through convention that we say, well, if it's got type relationship, this is what we mean is actually a link in the node graph to another entity. And you can see I've deliberately put in there some metadata saying, well, actually, this particular relationship is pointing towards another entity of type building. Well, that again is done by convention. Now, this is fine within your system because your system can work out because you have control of all of the data that, hey, this is a relationship, this is an object type, because you know what the attributes are. But you need to be a lot more strict when you are talking across organizations, because at that point, everything has to be entirely done by machine and not done by convention. Furthermore, you'll notice that the when I'm not talking about relationships, I can be more lax as to what I'm using for the word type. So in this case, I'm using type for data types. So the value, inverted commas, sensor, inverted commas, is a text value. Now, once again, you can define your various different types as necessary. There's only one example where there is a strictly defined type for NGSI-v2, and that is the GeoJSON format. You can see location in there, and there is, in this particular case, I have got a sensor in one particular location, but it's that string geo::JSON which is defined as saying this is where my location is, so that I can do things like geofencing or get data, which sensors are within a certain area, queries or subscriptions on the GeoQ parameter. And of course, this is NGSI-v2. This is standard JSON. There's no at context. It's very easy to understand. It's very easy to prototype your systems, and if you're in full control of your system, then it's very easy to use as a whole. Now, this compares with the NGSI-LD format, which is ever so slightly different. Once again, every entity must have an ID and a type, but instead of just having a value for every single attribute, you may have other sub property types of elements. So, for example, the category here has been defined as a vocabulary property. A vocabulary property being, in JSON LD terms, something which expands to an IRI, which is an at vocab. And you now look at the relationship. The relationship is now an object, because an object is always an at ID in the core context of the NGSI-LD. Temperature is a classic property. Now, the ETSI committee have defined that the temporal values are not time instant, but are observed at. And observed at is one of these keywords which is always used within an NGSI-LD format. And you notice that there's no longer a metadata element. What we have here instead is, in this case, we're using the standard non-reified properties, which are effectively properties of properties or properties of relationships, to define things like this is a relationship pointing at a building, or this is a temperature which was observed at a certain point. Now, in addition to property, relationship, list property, JSON property, vocabulary property, there is also geo property, and geo property is the same as the geo::JSON format for NGSI-v2. So we no longer got just values for everything. We've got different keys for the different types of data you're talking about. So a temperature is a property, therefore it has a value, but a controlled asset is a relationship, therefore it must have an object. Furthermore, either directly or implied, there is an at context to this element. Actually, strictly speaking, the at context is going to be an array of 2 elements, because you will have the path to the user's at context, which is defining terms like temperature or controlled asset or category, the stuff which makes your system run, but also it will also implicitly add in the core context, so that it defines what is a property. Everything here has to be mapped to the at context somehow. Now, there are multiple types of data space, and they range from very strictly defined ones to very loosely defined ones. You could imagine a data space, an integrated data space, where you have a rule book which says you just use one payload, you just use one type of context broker. So in this case, we say, okay, we're just going to use Scorpio 4115, which means that although you may well have different organizations sharing data here, they have already predefined that the interface will work, because I'm using one particular structure of data, I'm using one particular context broker. This is an example which could be used for example, with a lottery system where you've got a well-defined payload for your tickets, and every ticket selling machine will send data in the correct format. Now, a little bit looser than that is the unified data space, which says, well, I don't really mind whether you're using Stelio, Scorpio, whatever, as your context broker, but the payloads will be transferred using NGSI-LD, for example. So we're now no longer mandating in our rule book that we must use the a specific context broker, but we are saying we are using a specific payload. This is obviously makes it easier for organizations to join a data space, because they have more flexibility in what they're doing, but it makes it harder for the system as a whole to be set up in the first place. Now, even more loose than this is a federated data space, where you could say, well, actually, I don't really need NGSI-LD or specifically Scorpio 4.1 or whatever, but I need a mechanism such that all payloads can be translated into GeoJSON. So, for example, I could have a data space which consisted of some random geographic GIS systems, and NGSI-LD data is being pushed into this data space and what have you. Well, all the payloads must be GeoJSON, but we're no longer saying it must be transferable in such a system. So it's saying that there's a common meta structure. Now, it may be the case that you have some sort of adapter in front of the, say, the context broker to transform into the preferred format. Obviously, NGSI-LD will do GeoJSON directly, but it means that you could have a system where there are multiple different ways of dealing with your context data. This is important because NGSI-v2 is perfectly capable of creating an integrated data space. If you have purely NGSI-v2 brokers and NGSI-v2 context sources, you don't need to worry about the NGSI-LD machine readable mapping, because it's the case of, yeah, we're in control. We know what the format of the data is, and we know how it's readable. So you could easily have a data space with NGSI v2 farming system talking to NGSI v2 weather system. This is a standard registration. However, when you're talking about broader data spaces, you now need to start saying, well, how can I get data from other organizations which are offering their data in a somewhat different format? And this is where, as I've mentioned before, this is where Conway's law comes in, is that if I have my data in my structure and I'm doing it my way, then, and I want to share my data into a broader pool, then you, as another participant, you're no longer the head of the data space, you're just another participant, can't tell me, well, you've got to change all your data around. So you're no longer setting up something from scratch. You're saying, I need to have the flexibility of mapping my attributes, my names, my whatever, to a format that you're happy with, and you're able to use your stuff internally using your preferred short names. And similarly, I can do the same with mine. So this is where the LD stuff comes in, is that the LD stuff doesn't mandate that we have the same, precisely the same payloads. It's saying we have a mapping between those payloads using JSON LD rather than having a common JSON format. So what you will need if you're using NGSI-LD, and here is an example of two participants, one who's internally using terms in English, one who's internally using terms in German, is you will need a user context file. The user context file is mapping the preferred short names of your system to your long names. Now, I deliberately structure my preferred, my terminology in this sort of fashion, because you can then see what you actually need rather than having everything in, say, alphabetical order. The first part of a user context file is usually defining terms of authorities. So, for example, if you use the data models from schema.org, you will define schema.org as one of your authorities, because it makes it easier to define your attributes further down. So we've got things like schema.org is an authority, and you've got schema.org/female, schema.org/male as part of our enumerations. It's obviously best to use authorities which are publicly available and out there, but obviously you can imagine a data space where we start off, okay, we'll define our terms because no one's set up a data space on our terminology. You've got things here like your smart data models, or in my case, I'm specifically looking at the agri-food parts of smart data models. Furthermore, you should, if you're defining data types, refer to the RDFS or XSD types, because these will become very useful further down when you're structuring data. Second point is, obviously you have data in your system. Not necessarily all of your data will be passed to your data space, but every entity within that shared data will have a type. So entity type names need to be defined. I've defined things like building, device, animal, person, and what have you. But thereafter, every attribute of that data will also need to be put in. Now, you could imagine there's, going back to our thermometer, you could have an attribute like temperature, and it could have metadata NGSI-v2 saying this data is provided by that device. Well, that metadata would also need to be in this user context. And the reason why you need it in this user context is that every single term will need to be defined in your user context. Now, having defined all your attributes, your keys and your key values, the final part is the definition of your enumerations and data types. So going back to the NGSI-v2 payload, we've got things like, type is text, type is float, type is integer, type is postal address for that matter. All of these things also need to be placed in there, because those types are effectively an at vocab. They're expandable. So when we're saying, this JSON object is a postal address, we want to be able to refer to the fact that, oh, this is really a schema.org postal address. And once again, I can't just say postal address as a string. I need to make it into an expandable IRI or URI to get this to work. But you can see looking at the keys here, I'm free to choose what the names of my my attributes. If I want to use breed carved by fed with, fine. That's not a problem within my own internal systems. Once again, for the German Rasse gekauft von gefüttert mit, I can use whatever I want as my internal attributes, which would then be moving into my special source, my processing, my microservices when I do a subscription in my either my V2 system or my LD system. The core context is structured in the same fashion. The core context has got an attribute @protected, which means that you can't override these terms, but it does once again define a series of authorities, one of which is etc, another of which is GeoJSON, because GeoJSON LD is a thing, but it also maps a few attributes to JSON LD terms. So the ID in every single entity is a map to the @ID keyword, which is saying this is a thing. And similarly, the type is to @type, saying this is a thing of type whatever. This is so that this thing is machine readable. There is a list of data type names which are used within NGSI-LD, like property or relationship, and also a few other elements like date time needs to be defined for the temporal attribute, because things like created at, observed at are of type date time. There are obviously multiple attributes which are in there, like unit code and observed at, which we had earlier. They must be defined. If they're defined here, you don't need to define them yourself. And finally, and this is a problem when you are looking at data spaces, is that to make sure that your JSON LD syntax is complete, it defines a default context, the @vocab at the end. So if you fail to define an attribute, it will actually map to this default context, which is fine. It'll work within your system, but you think about it, when you're sharing your data with other organizations, you don't want to use the default context, because that's like going back to defining things by convention. So what can NGSI-LD do which NGSI-v2 cannot? NGSI-v2, NGSI-LD is for data spaces and highly distributed systems. So if you have, for example, a data about your cow, which is coming from your vet, coming from your farm labourer, coming from your FMI system, and they're all owned by different people, because I'm a farmer, I'm not the vet, I can get information about multiple different systems all at once. And of course, it can federate all three types of data space. Now, this is for data exchange, quite simple. Now, there are also multiple different ways in which you can set up a registration using NGSI-LD. Either I can say I will get data from all my systems together, or I will get data saying, I've got, say, a device, I'll get data from that IoT agent as a registration. So there are multiple different types of registration on NGSI-LD. There was another webinar go into more detail for those types. Now this contrasts with NGSI-v2, and NGSI-v2 has got other advantages because it's not trying to do the highly distributed case. So, for example, there are elements such it is possible in NGSI-v2 to do an update of a value directly, or increment a value, because what that's saying is I have a device, I will add 1 to that device. Well, that's because I have my context broker, and my context broker is the source of truth for my system. That's great. It's not the case that I have a context broker and it's federated with another 20 different context brokers, and they all have access to that value. So there are things like custom subscription formats. You can use Jexel, for example, to output your data into the format of your choice. And of course, you have absolutely no need for any of this context hosting. But its main use case is for much more of an integrated system. I have an interoperable interface which I can use for whatever I need within my control, and I can switch in new IoT devices or a new processing element via a subscription or a registration to go within my system. Furthermore, NGSI-v2 is able to innovate on elements such as transient entities, because it's got the ability to clear out its own database. The key point here, of course, is that the payloads are simpler. It makes your development faster. If you're not looking at a data space, v2 is an excellent choice. That being said, at some point you might want to get your v2 to potentially push some, not necessarily all of its data, into a data space with NGSI-LD. So the best practice here is to make sure that when you are defining your data types, your data models, is that they should align with potentially what's happening with your partners in your data space. Classic example of this is NGSI-LD wants URNs for its IDs, and it's always been the case that you should use URNs for your IDs because and there's a convention for this. It's saying you use the protocol entity type followed by the identifier for defining your IDs, because that means that when you are defining a relationship, which also in NGSI-LD is an @ID, therefore must be a URN, it's easier to define this is linking over there. You can see that there are multiple ways you can define a relationship. In NGSI-v2, obviously it's a value, but NGSI-LD defines 2 different types of relationship: either relationship, which can be either an ID or an array of IDs, or list relationship, which is always an ordered list of list of IDs. You can see here that it's very similar, but we're effectively defining how the attribute is working by the naming of the type. You're using the naming of the type by using the preferred terms here for the NGSI-LD. Once again, for the overall entity, you should be using some sort of existing data model. They will already have names for them, so you will want to map onto an existing data model. So let's say you've got buildings. Buildings will follow, say, the smart data model's building format, because obviously when you are pushing data into a system, it's implicitly saying, if I've got a building, it's probably got a location, a name, a number of floors, and so on and so forth. So the attribute names for the various attributes should also align with the preferred model. Nearly everything in NGSI-v2, apart from obviously geoproperty, nearly everything is effectively a equivalent of a property. You can use the NGSI-LD attribute types for consistency. So obviously, if you have something, say type is property, it's a property, right? However, you can also use the type attribute for the data type of the value. So in this case, we're saying type is text. But if you want to go and start using the various attribute subtypes in NGSI-LD, then it's a case of, okay, I will need to send the type to a value and then structure my data accordingly. So if I want to mimic a language property, it's probably best to call the type language property and follow the data type as defined by the IETF for my data. It makes sense. Now, as I mentioned before, GeoJSON is the one thing which NGSI-v2 specifically defines. You use GeoJSON, but it's going to map to a geo property. NGSI-v2 has this metadata element, which means which should hold the various information about that particular attribute. Now, unit code is the preferred term for your units of the value in question, always has been, and the recommendation is to use the UN CFAC terms. There's a huge list of these. For example, CEL is for Celsius. If you are trying to deal with things like something pointing at something else, like the object type, you can put a metadata element in there saying that this is pointing to, in that case, CL as well. The timestamp, the NGSI-LD preferred name is observed at. So observed at is used, but obviously time instant is also frequently used, so it can be used mapped to observe that later on if necessary. If you're reusing all these core terms, you should, which are in the NGSI-LD core context, you won't need to put them in your own user context. They're defined already. But what you really, really shouldn't do is try and rename things or use things which are not necessarily banned, but would be banned in NGSI-LD. So, for example, having an attribute called coordinates, which is actually already part of the GeoJSON specification, is a very, very bad idea. It's not banned in NGSI-LD v2. It would not work in NGSI-LD. It's a bit like trying to come up with an attribute called ID. An attribute called ID is completely and utterly impossible in NGSI v2 because an ID is a URN. So a coordinates is an ordered list of an array of numbers, ordered list. That's the way it has to be defined. Therefore, don't do that. Use the existing data models to try and get your system working properly. There are ways to define your value type, multiple different ways you could define your data type. If you just define in NGSI v2 with type property, you've not actually got anything beyond the definition of, yeah, this is a property of some sort. If you want to imply that the value is somehow an integer or a string or a text or what have you, you can in NGSI v2 rename the type according to your preferred system. That's perfectly doable. It is also possible to push this to, say, metadata. So you're going to have a value type metadata element call it there. This contrasts with the way it works with NGSI-LD, where obviously your type has to be one of those core context things, so it has to be property. So you are forced in NGSI-LD to put the values further down. So you can either have a property of a property, like a value type on the temperature, saying this is an integer, or you can use JSON-LD syntax directly on your values. I personally think that this is unnecessary in most cases. It's easier to have an attribute to define this, and actually then you can work the numbers. When you do this, in NGSI-v2, if you are going to define, your type is integer, your type is float, your type is whatever, it is important to make sure that your user context includes those terms as well, because those terms are not defined in NGSI-LD. So I'm now going to show a little demo of how to combine the two systems together. You can see that I'm actually going to have an Orion context broker at the bottom of the system, which is JSON only, which has got my supermarket stores in it. I will then have an adapter in front of my context broker, which will then offer the data as LD, and I can then connect it to another context broker such as Orion LD or Scorpio or Stelio. You can see that at the bottom there is an implicit user context because we're not defining this in NGSI-v2, never will. The layer above, this is when we start pushing some of our data out into a looser data space, must have at least one fixed user context which is available, which defines the terms such that the LD broker can understand it properly. And of course, when you have a context broker which can understand JSON LD, it can do the flexible multiple user context. So let's bring up a context broker. I will actually run with Scorpio rather than Orion LD because I have no preference as to which LD broker I'm using. But of course, my background data is being held in an Orion NGSI-v2 system. So just wait for it to come up in a few seconds. It's getting there. There we go. And it's loading up some data on the right system. So let's go here, Postman. So if I just look at my Orion v2 broker, I have got, I've been running for a few seconds. It's Orion version 4. I can, of course, read data directly out of my context broker in Orion v2 context broker in v2 format just by sending a usual v2 request. And you can see here that I've got an address, I've got metadata. I'm deliberately using the normalized format because it's easier to see. Obviously, the simplified format in both cases is basically the same, but you can see all the difference. I've got some metadata in here. I've got my relationship. My relationship here is the owner is pointing to a person. I've got my I've defined categories of vocabulary property following the rules which I've described beforehand. Now, what this means is because I've defined the system here, I have the possibility of just requesting it through my adapter, and my adapter is saying, okay, I will offer the same data in NGSI-LD format. And you can see now that object type, for example, is now a non-reified attribute. And furthermore, I will offer a fixed context file to define all the terms in my system. So this is an NGSI-LD output, which is just all it is it's a thin wrapper which lightly modifies the v2 payload and adds in a fixed context file. So these are the terms in my NGSI-v2 system mapped properly. So I've got things like a building or a store or a shelf or whatever, which are defined properly. I would also add in things like integer or float or whatever. Now, you can see, once again, there are other endpoints which are within the available in the system. Now, obviously, the Orion version endpoint is specific to Orion itself. According to the latest NGSI-LD specification, this is defined under info source identity. And if I just go through that through my adapter, it gives me a type of context source identity, and all that data which Orion was offering me is now placed into context source extras, which is a JSON property, which means, and it says I've been up for a certain period of time, and it's giving me a context source alias, namely the adapter, which is Lepus. If I can obviously ask for type store, not a problem, and I can get the get the data out with multiple entities in there. But if I do the same thing through my adapter, again, if it's using my preferred NGSI-v2 terms, store, for example, it will actually give me back my data in NGSI-LD format. And once again, you can see I've got a geo property in there, and I've got my vocabulary property here. And if I look at my owner, it's saying object type. Now, the NGSI-LD specification changes slightly as each new piece of functionality comes in. So if you add in an additional prefer header when you make the request, I'm going to say I want to get my data as NGSI-LD according to specification 161. I can get that, and you'll notice here that the object type has now disappeared because that's not supported in the 161 payload. So you can set up your preferred federation when you are getting another context broker to talk to your V2 system to say, hey, I would like to get buildings. I would like to get buildings using NGSI 1.6 because I'm a 1.6 broker, let's say. However, you also, within the source context info, define a key called JSON-LD context. This is saying whenever I talk to the registrant of this system, all terms must be translated using the fixed context which I have defined for my V2 system before sending it. So if, for example, I have called something name and I call it something different in my V2, it would then do an expansion compaction operation to change the attribute name before passing that data further down. So I'm now looking at my LD context broker. I can send data there, and I can then read from my context broker, which didn't have that data in there, to get this as part of the federation. And you can see I'm now within my LD context broker, I'm getting the data which is actually stored in the V2 context broker in the format I prefer. Because this is now the LD context broker, I can even look at my headers using an alternate context. I can then I'll do the expansion. The expansion compaction operation is done by the LD context broker, and you can see that address is now addresser, and category and inhaber have been set for those values as well. I haven't mapped that because I'm using a 161. I haven't mapped the vocabulary property here yet, but you could also change the names of these attributes to work as well. Now, the majority of the endpoints which are available on NGSI-LD are available on the wrapper, so I can actually do things like I can create an entity, I can add new attributes to that entity, and I can read an entity, saying, okay, here, and it will give me my values back. Now, this looks like it's an NGSI. It looks like it's an NGSI LD system. However, if I now were to change that down to a V2 system, I would be able to get the information as well. The basic operations for LD are obviously CRUD, but for federation ops, you need CRUD and subscriptions. And it is also possible to create and fire subscriptions and notifications using this this function, which then sets up the subscription in Orion. Orion then sends out its subscription. It's a custom subscription because it's using a special header back to the wrapper, which then translates the payload from V2 to LD and passes it on. So you're able to use this data within the broader NGSI-LD federation. One thing you could also do, of course, is you could use the same. If, let's say, you've got lots of data in your V2 system and you're only wanting to federate one type of entity, let's say, then you could obviously use a subscription to raise the changes and use something like Apollo to put that to another LD broker and just offer the LD broker as well. So the key point here is that when you are adding a federation here, you can you use this JSON LD context element in your core context info. You can use prefer if necessary. Obviously, multi-tenant is also supported. The NGSI LD term is NGSI LD tenant, but you would map to a specific FIWARE service, NGSI-v2, if necessary. It's what the context source info does is it adds in the additional headers to go through when making a request to the wrapper. The prefer header, as I mentioned, can be used to do this. A prefer header may not be honoured. It's possible that it's prefer. It's nice to haves rather than definitely the case. And some of this these values are being formally added by the ETSI specifications. So this is potentially subject to change. And that is where we are currently at. So, in conclusion, NGSI-v2 is JSON, NGSI-LD is JSON-LD. Understand what the difference is and why you need to have both systems. It's not the case that v2 is going nowhere. v2 has got a very good system, reason to exist. It works really well with individual applications offering web services, devices, what have you. There are a lot of NGSI v2 systems out there, probably more than there are LD at the moment. However, LD is very much the front runner for a broader distributed data space. The JSON LD context is obviously the thing which needs to be mapped in all cases. And the key to getting a NGSI v2 system to talk to a wider data space is to use an adapter. At the moment, this adapter is lying on my own GitHub repository. I'll probably pass it on to the FIWARE repository in due time. And you can use a fixed context to create make a NGSI v2 context broker as a participant within a data space. So thank you very much for listening today. I hope you've learned something, and please enjoy the rest of your day.